Venus. Most people have heard it called Earth's twin, same size, same mass, similar structure, but that similarity disappears the moment you look deeper. In reality, Venus is one of the most hellish places in the entire solar system. So what exactly is on Venus? Why is it so dangerous? And could humans realistically survive there? In this section, we explore Venus in full scientific detail. 1. Basic characteristics of Venus. Venus is the second planet from the Sun. Its average distance from Earth is about 41 million kilometers, making it one of our closest planetary neighbors. In size, it is nearly identical to Earth. Earth's diameter, 12,742 kilometers. Venus's diameter, 12,104 kilometers. This is why it was historically called Earth's sister. But the moment you reach the surface, that comparison becomes meaningless. 2. Temperature, hotter than Mercury. Venus has an average surface temperature of 462 degrees Celsius, 864 degrees Fahrenheit. Yes, hot enough to keep lead melted. It is the hottest planet in the solar system, even hotter than Mercury, despite being farther from the Sun. Why? Because Venus's atmosphere is almost entirely carbon dioxide. This creates a runaway greenhouse effect, trapping heat like a giant oven. Once heat reaches the surface, it can't escape. The result, a constant, unavoidable, deadly temperature. 3. Atmospheric pressure, like being crushed under the ocean. The atmosphere on Venus is about 90 times thicker than Earth's. This is equivalent to the pressure at 1 kilometer beneath the ocean on Earth. If a human stood on the surface, their lungs would collapse, their helmet would crush, their suit would be flattened instantly. There is currently no suit on Earth capable of surviving that pressure. 4. Atmosphere composition, a toxic hell. Venus's atmosphere isn't just hot and dense, it's toxic. It contains 96% carbon dioxide, 4% nitrogen, upper layers of sulfuric acid clouds. If rain falls on Venus, that rain is sulfuric acid. Fortunately, it evaporates before reaching the surface, but being inside those clouds would still be instantly fatal. 5. Winds and storms, superrotation. Venus's incredibly dense atmosphere moves like a huge churning ocean. In the upper atmosphere, winds reach 300 kilometers per hour, 186 miles per hour. This phenomenon is known as superrotation. Even though Venus rotates extremely slowly, its atmosphere circles the planet multiple times faster. So on Venus you have a constant moving blanket of poison, invisible acid particles, high pressure, high-speed winds. 6. The day-night cycle, a day longer than a year. Venus is extremely slow to rotate. One day on Venus lasts 243 Earth days. 1 year on Venus lasts 225 Earth days. This means the Sun crawls across the Venusian sky at an unimaginably slow pace. 7. Surface appearance. The surface of Venus is rocky, dry, and volcanic, a landscape of death. There are thousands of volcanoes, lava plains, and jagged rock formations. The Soviet Venera probes managed to send a few images, but they only lasted about 2 hours before melting and failing. Summary: the surface of Venus is lethally hot, crushingly pressurized, filled with poisonous gases, covered in acid clouds. Violently windy, volcanic, and unstable landing on the surface is completely impossible for humans. But there is hope. The upper atmosphere of Venus offers something different, and that's where the question becomes interesting. How could humans survive on Venus? Not on the surface, but 50 kilometers above it. The surface of Venus may be deadly. But something surprising happens 50 to 55 kilometers above that hellish ground. In this upper cloud layer, conditions suddenly become much more Earth-like. Here temperatures drop to around 20 to 30 degrees Celsius, and the atmospheric pressure becomes almost identical to that of sea level on Earth. So if humans ever survive on Venus, it won't be on the surface. It will be above the clouds, living inside massive floating structures. NASA has already explored this idea with a project called HAVOC, High Altitude Venus Operational Concept, a plan for human cities hovering in the atmosphere. So the concept of floating colonies on Venus isn't science fiction anymore. It's a serious scientific possibility. But what would such a city look like? What technology would it require? Could humans really live, work, and survive above one of the most dangerous planets in the solar system? Let's imagine it together. Venus has such a dense atmosphere that the air we breathe, a mix of nitrogen and oxygen, is lighter than Venus's carbon dioxide-rich air. This means something incredible. A habitat filled with breathable air would naturally float in Venus's sky. Just like a helium balloon floats on Earth, we wouldn't need helium or hydrogen, just ordinary air. This alone changes everything. The surface may be hell, but the cloud layer could carry us like a giant ocean of dense gas. Of course, that doesn't make things easy. Even at these altitudes, the environment is harsh and extremely dangerous. For example, there are the sulfuric acid clouds. Much of Venus's atmosphere is filled with microscopic droplets of corrosive acid. So every external surface of a floating colony would need to be protected by special materials. Similar to the heat shields used on spacecraft, acid-resistant polymers, Teflon-like coatings, even titanium structures would be essential. Technology is the heart of survival here. Inside the colony, life would feel completely different. Controlled temperature, stable pressure, balanced oxygen, a huge airborne city drifting peacefully in the sky. Now imagine an astronaut stepping outside. Because the pressure in this layer is close to Earth's, the suit wouldn't need to be thick or pressurized like a typical EVA suit. Instead, it could be lighter, more flexible, but the exterior must be fully acid-proof. A single drop could destroy equipment instantly. Then comes the issue of water and oxygen. There is water vapor in Venus's atmosphere, but in small amounts to collect it, colonies would need continuous filtration systems. Most water would likely be recycled. Over 95%, similar to but far more advanced than the systems used on the International Space Station energy, on the other hand, is where Venus gives us a massive advantage. Venus receives almost twice as much sunlight as Earth, so a floating colony could generate enormous amounts of solar energy. As long as the panels were protected with acid-resistant materials, energy would never be a major problem. However, these colonies wouldn't stay in one place. The winds in Venus's upper atmosphere are extremely strong. They circle the entire planet every 4 to 6 days, so a floating city would constantly travel around Venus, like a passenger on a planet-sized conveyor belt. A non-stop journey, forever moving with the winds. But deep dangers still lurk. Massive electrical storms, sudden changes in wind layers, atmospheric turbulence unlike anything on Earth. To survive these advanced AI systems, automatic stabilization engines, and sophisticated sensor networks would be required. Always on alert, always adjusting. And then there's food. A true colony must feed itself. Hydroponic agriculture, growing plants without soil, would be the heart of the ecosystem. Plants would produce oxygen, absorb carbon dioxide, recycle nutrients, and provide psychological comfort for humans living far from Earth. A floating colony could become almost entirely self-sufficient. In the end, think about it. Human beings drifting inside a thick layer of acid clouds, hovering above a deadly world, yet living in a bubble of safety and light, a tiny Earth, floating above a planet that would destroy anything that touches it. That is what survival on Venus would look like. Dangerous, extraordinary, and strangely beautiful. A world where hell is only a few kilometers below you, but above it, humanity could find a way to live. Venus. On one hand, it's one of the most dangerous planets in the solar system. On the other, hidden within its clouds, lies a surprising opportunity. Just a few dozen kilometers above that fiery, molten surface, there exists an environment far closer to human comfort than anyone would expect. Venus reminds us of something important. A planet's habitability cannot be judged by its surface alone. Sometimes the hope for life hides in a thin layer of atmosphere we can't see with the naked eye. So could humanity truly live on Venus one day? It's difficult to give a definite yes or no. But what we can say is this: what seems impossible today may become science tomorrow. Centuries ago, reaching the moon was unthinkable. Colonizing Mars was considered pure science fiction. And floating cities above Venus? Unimaginable. Yet now we know, if technology continues moving in the right direction, the upper atmosphere of Venus could one day host one of the most extraordinary human colonies ever conceived, with abundant sunlight, nearly limitless energy, and massive floating structures gliding above the acid clouds like futuristic airships. People could live there, grow plants, conduct research, and build an entirely new culture. Maybe Venus will never be our second Earth, but perhaps it will become the first place where humanity proves that life can adapt to completely alien conditions. And maybe one day, a child looking out from the window of a floating colony, gazing down at the golden glowing clouds beneath them, will say, "We live here, in the skies of Venus." It may sound crazy today, but throughout human history, every great leap forward sounded crazy at first. Humans are creatures of Earth, yes, but we are also explorers of the universe. Every discovery leads us to the next step. Who knows? Maybe Venus isn't just another planet. Maybe it's the beginning of a new definition of what's possible.